Good day, ladies and gentlemen. In our last class, we discussed formula method, and today I promise I will be treating real roots today. Real roots, real roots today. Okay, now probably it's just a. I just want to make you understand what do you mean by real roots. Why is it called real roots? Why is it real roots? I don't know if you've ever solved some quadratic equation and you find out you can't arrive at the final answer of x, and you feel like, what kind of question is this? It's very impossible, when you insert the square root of anything, then find your calculator is giving you mass error. Now you're wondering, then how do I solve this? Then sometimes you solve a quadratic equation, then you find out your the values of x, they are both equal. Say your x equals to 3 and still equals to 3. How come? How is it equals to 3 at the same time? Both answers equals to 3. Why is alpha equals to beta? It's common like that. But the normal one, general one that is common is when you get different answers. And that's what I want to explain. This is it. What makes a quadratic equation real? What makes it imaginary? What makes it what makes it perfect, ideal? Okay, now there's the point. I will explain the theory at the time, so I would like us to be attentive. Now, you must have done, we're told there are 4 methods of solving quadratic equation. The first one is factorisation method. The second one is completing the square method. Completing the square method, right? Then this third one is formula method. Then the fourth one is now graphical method. I'm sure you are aware of all these methods in quadratic equation. Now the point is this: in graphical method, probably when you are having a graphical method, you'll be told some kind of things. You'll be told when the graph, this is your y-axis and this is your positive x-axis, right? They'll tell you when your graph is like this, then your a is what? Positive. That's going to be having as squared plus or minus bs plus or minus c. It's my problem. And sometimes when it is like this, then you'll be told your a will become negative. That will be having minus as squared plus or minus bs plus or minus c equals to 0. That's my problem, isn't it? Now, that is determined by the position of the graph, and that is where minimum and maximum values comes in quadratic equation. So no, we are not treating that now. Minimum, that will be the next minimum and maximum values. Now that's where they're coming from. So now we will now be checking, okay, how do we get to understand why is this, why is this like this? There are some laws regarding this. So I can give you a quadratic equation, you can tell me my a must be positive, because if it is not positive, then I'm wrong. Very easy. Now, same thing, you can give me a quadratic equation, and as looking at it for a while, maybe less than 5 seconds, I can tell you this quadratic equation, you cannot arrive at the final answer unless you be applying complex number. So that's just the point. So the reason why you say, oh, he's a genius, he gets that, is because he knows the basic rule and some principles that are meant to be right, to be correct before they can work. Now, in our quadratic formula, we were told it is known that line x equals to plus or minus root b squared minus 4ac all over 2a, right? And have you ever thought of why they will say this thing can be regarded as capital D, and they say let my D be the determinant? Why do you think it's like that? Because the reason is that this D tells if it will be real, it will tell if it will be perfect or imaginary. This D is what judges it, and the D is equal to b squared minus 4ac, just as you can see. It is equal to b squared minus 4ac. So meaning this one determines if it will be real, if it will be perfect, and if it will be imaginary. Everything lies in the end of this thing. It is what determines it. So if it is saying it will be perfect, then it will be perfect. Nothing past that. If it says it will be real, nothing past that. It will become certain. And if it says this thing will never, it will just be like an illusion. It will only be, you only imagine it. That means it becomes a complex truth. This is imaginary root of complex truths. You get the point? So that when it becomes complex and you'll be like, oh, I'm tired, and I calculator could never solve it there. How will I? There's the point. Now you understand why they are like that. And last time I said how we know it is a perfect square. I'll let you know when I get to the second phase of what we are doing now. Okay, now so that's just that about this. Okay, so determinant is equal to b squared minus 4ac. Now I want to give you three distances. Now okay, I think there are 6, probably 3, A and B. So this is fig 1A and this is fig 1B. So this is fig 2A. So we have fig. Okay, let me just put somewhere here. It can be anywhere. But the point is just passing the same information. 2B. Okay, then pardon me for using fig. Probably this is my textbook, but all the same. Let's start representing this something at least. Okay, let me assume this is like this now. Okay, this is fig 3B. Now, this one is explaining a real. This one is explaining the perfect, and the last one explains the imaginary. Now, how is this real? Why is this perfect? Why is this imaginary? Now, when we're studying quadratic, we are aiming at something, and what we're aiming at is the value of x, that is the two roots, alpha and beta, which are the values of x. That's what we are aiming at. That's our target. That's what we're looking for. Now, so meaning, and this is my x-axis, this is my y-axis, positive y, positive x, negative y, and this is my negative x. Same thing does for everything, right? So at this point, I have my curve cutting the x-axis. And when you're doing your graphical methods, you will certainly be told wherever your graph cuts your x-axis and the values of your x, right? Okay, then same thing as here, it is cutting it here, and it is cutting it on a axis. It is cutting where it's supposed to cut, in the sense that there is no way. Let's assume this is my alpha, this is my beta, alpha, then beta. I'm getting a real value. So if this is -5, this may be -2. If this is -4, I can say this is even sometimes not once it is like this, it can even be like this, provided it is cutting the axis, the x-axis at 2 points. But most times this can't be, it's probably it's very scarce for it. But the concept is just it has to cut the x-axis in 2 phases. Also touching the y-axis one way or the other. I hope what I'm saying is clear, because y must be involved. That's why this one is impossible. It's impossible for us to have this because it's not touching y anyway. It's very impossible to have that. So, but as for this, so it must cut x in 2 places and y in a place. It's a must. So I hope what I'm saying is clear. Okay, now, so it's called like x and alpha and beta, same thing. But so I can say in this place, my x value is equal to alpha and is equal to beta. Simple as that. I hope I am clear. Now, as for this, so probably we can have this, have it here, but it has to cut it one way or the other. It has to cut the y-axis one way or the other. But the fact, not really composed, but the fact is it must cut the x-axis in 2 places, so that you can have 2x values. You get it? So that's about real values. So when we're talking about real values, then my determinant is greater than 0. I'm coming. Let me clean all of this. So I'll now trash them out one by one. The determinant is what? Must be equal to 0. The determinant must be greater than 0 rather. Now, what's the determinant? My determinant is equal to b squared minus 4ac, and this same thing minus 4ac must be greater than 0. Must be greater than 0. Why must it be greater than 0? The major reason why it has to be greater than 0 is because of your formula. You know, our formula is x equals to minus b plus or minus root. Let me use it over 2b. Let's now assume my d. My d, it must be greater than 0. So if my d is equal to 1, I can have root 1. Root is equal to 2, I can have root 2. It must just be greater than 0. So I can have a definite value. So root of any positive integers and 0 will always give us a real number. That's the reason. So if I should have root 5, normally it will give me a true number. I think 2.32 or so. Yes, I think 2.32. Now if it's giving me this probably 2.32, I can add it or subtract it from my b. So I can get a real value. But for instance, assuming I'm getting, even if it is root 0, it will still give me 0. Yes, that's the fact. Root 0 is equal to 0. So 0 plus this one, it will still give me a root. So it must be greater. Probably root 0, this one for 0, it is another aspect actually. But the point is, it must be greater than 0 for you to get 2 real roots. I know that's true. So that's that about the real root. That's that about the real root. So that's just the major reason why it has to be there. Now for the perfect square, for the perfect root rather, this is when the value of the alpha is equal to the value of the beta. You don't get it? That's when the value of the alpha is, or maybe you can have it like this too. That's when the value of the alpha is equal to the value of the beta. So at this point, I have my alpha and I also have my beta. I have my alpha and I also have my beta. They are both equal there. So that's how you can solve a quadratic equation and find out your x is equal to, is equal to 3 and your beta is also equal to 3. They are both equal. Why do you think we have that? That's because of what? It is a perfect root. So in this case, my determinant is equal to 0. Yes, it is equal to 0. My determinant here is equal to 0. It's not greater than 0. It is exactly 0. And what's my determinant? It's going to be b squared minus 4ac. Isn't it? So now, if I should have my s equals to minus b plus or minus root d over 2a. So if my d equals to 0, definitely I'll be having my s equals to minus b plus or minus 0, right? All over 2a, isn't it? So automatically my s maybe plus or minus 0 is equal to whatever I have here. So my s will be only one value. There's nothing. Plus or minus has been cancelled out. So we are having just a, so if my b is 5 and my a is 1, so if my b is 6 and my a is 1, I'll be having minus 3. So the both of them will be having a minus 3. For instance, okay, let me draw. For instance, when I have something like this, the both of them will be having minus 3. Sorry. Okay. As me, my b. Okay, my b is 6. Let's say my b equals to 6, then my a equals to minus 1. So my x will therefore from this from that it will be equal to what? 3. Probably. Yes, it will be equal to 3. This is not supposed to be here. But this, it will be equal to 3. Right? So and normally here my a is always negative, and that's why I'm having minus 1. So here I'll be having 3. Same thing, 3. So x will be equal to 3 and b. Why? Because plus or minus has been automatically cancelled out. It doesn't exist anymore. So probably if you finally determine your quadratic equation the perfect square, you can just say your x is equal to minus b value. As simple as that and get a final answer. That's all. So I hope that's just a shortcut formula. Just a shortcut formula for finding the value of x in a perfect square of any equation, any quadratic equation. We hope that's clear. So that's that about perfect. And there's a way I said I will explain how you can know if your quadratic equation is a perfect square. It is here already, only if you can see it. Now I said once your d equals to 0, definitely it is a perfect square. So once your b square minus 4 is equals to a perfect square, this is the formula you use. So if you are given, let me think, s squared, okay, if you are given, I'm coming, okay, s squared minus, okay, here I have plus 2 plus 4x equals to 0. Sorry. Okay. Plus 4. Oh God. Okay, sorry, let me think of an equation. So, equals to 0, right? So s squared plus so minus okay. Let me assume I'm given this question. S squared plus 2s plus 1 equals to 0. Question. I'm not asked. Check if this is a perfect square. The point is this. This is my c, this is my a. My a is equals to 1. Just input it. Now from here, this is the formula, general formula. But I now broke it down so it will be easier. Probably you can easily remember this. I don't know, but you can make this sort of formula by saying b square equals to what? 4ac. Then root both sides. No, this cancels. So my b will become square root of 4 is 2 root ac. So once your b is equal to 2 root, it's just a perfect square, which you can apply now. So now I can say my b is therefore equal to, what was my 2 here? What was my a? My a is 1 times, what was my c? My c is 1. So my b equals to 2 root 1, right? My b is equal to root 1 is still 1. So 2 times 1, my b is equal to 2. Once I've gotten my b now check the question you are given. Is your b also equal to 2? Once it is equal to 2, then definitely is a perfect square. I don't know if I'm clear yet. I'm not sure if I'm clear yet. But let me clarify it. Let me use the general formula instead of the one I deduced. Okay, now this is the point. My b squared, what's my b squared? My b here is 2, right? 2 squared minus 4 times, what's my a? 1. What's my c? 1. If everything can give me 0, definitely is a perfect square. 2 squared was 4 minus 4 times 1 times 1 is still 4. 4 minus 4 is equal to 0. So means it is also equal to 0, meaning it is true. So therefore it's a perfect square. That's what you time is the perfect square. So the other time in that quadratic formula, what we had, what we were solving then was, let me give you so I can just solve it now. We had s squared, right? Then you have plus b over as, right? Plus b over 2a all squared. So if I'm to check now, I'll just apply. What's my now b squared minus 4 is equals to, it must b squared minus 4 must be equal to 0, right? So let me check my b. My b is b over a all squared according to it. B squared minus 4 times, what's my a is 1 times, what's my c? B over 2a all squared, isn't it? So here if I split it, I'm having b squared over a squared, right? Minus 4 times 1 is still 4. So let me split this one to b squared over what? 4a squared, right? So I'm having b squared over a squared minus 4b squared over 4a squared. This cancels this. 4 cancels 4. So I'll be having what next? B squared over a squared minus b squared over a squared. They are not the same thing. So automatically they will give me 0 at last. Therefore it's a perfect square. So once you've detected it's a perfect square, I can even solve that question I gave. This s squared plus 2s plus 1 equals to 0. I can solve it easily. Yes, how will I factorize it? I will just say, remember the formula. What's the formula? My a x, isn't it? Plus the remaining of my b plus the minus root c all squared. And all this one, I'll factorize it already. I'll factorize this expression. I'll factorize the expression already. So now, what's my a? My a is 1, so therefore it is x. This one equals to 0. If it is as this is an equation, I'll make it equal to 0. If it is not an equation, I'll just use it alone. That's the expression. So since it's equal to an equation here, it's also equal to an equation. Or better still, let me clean, then we explain the concept. What I was explaining the other time. So that's that about real roots actually. So let me explain to you that one. Okay. Now I want to solve this question. Now I said whenever now I want to check if it's a perfect square first. So my b square minus 4ac must be equal to 0. Right? So let me check now. So what's my b? My b from here my a equals to 1, my b equals to 2, and my c equals to 1. So my b is 2 squared plus 4 times 1 times 1. Right? Equals to 0. So 2 squared is 4. 4 minus 4 equals to 0, which is true. So definitely it's a perfect square, justified already. So since you discovered this in the perfect square, I can solve it easily, factorize it easily by using that formula, which is as plus or minus root c all squared. Since it's an equation to be equal to 0. So now let's apply. So what's my a? My a is 1s, right? Plus my b determines. So if my b is plus, it will also be plus here. If my b is minus, it will be minus here. So minus plus rather root. What's my c? My c is 1 all squared equals to 0. So I'm having x plus root 1 is still 1. That's equals to 0. So I'll split it. X plus 1 equals to 0. I'm through. So if I'm to split it, x equals to minus 1 and x equals to minus 1. So x equals to minus 1 for both of them. So you see that their roots are equal. So even if I'm to reconstruct the graph, since the a is positive, the graph will be like this. Okay, minus 1. This is the graph. That's as simple. So this is a perfect root because it's a perfect square. I can also find this using this formula. This is the first formula for finding s. Whenever you find out it's a perfect square. And the other one I gave you is that whenever it is equal to minus 0 over 2a. So your x is equal to minus. What's my b? 2 over 2 times. What's my a? 1. So minus equals to minus 2 cancel 2. Minus 1. So for both roots, it's just minus 1 comma minus 1. So in this case, my alpha equals to my beta. Both formulas worked. I hope that is clear. So that's that for perfect root. And for imaginary, it is imaginary because my determinant is less than 0. So I don't know if you can just try it if I finish filling this. Press root minus anything, any number. Root minus any number will always give you certain. So that's for you to solve it, you must understand the concept of complex numbers. For you to solve that. So complex numbers makes you solve it. So that's when your d is less than 0. So if I should have in the equation, 1 over 2a, if I should have minus anything, it always give me what? An imaginary answer. So that's using your s minus, it to become, if I should get my final answer will be minus d, minus determinant, right? All over 2. And square root of minus anything, we always give you as minus 0. That's it. So except in complex number. A complex number will now make it x equals to minus 1 plus or minus root d I. So you can now look for d. So when you now look for root d, you can now solve it. But your final answer will now be, let's assume your final answer equals to x. Your final answer will surely be x, not b. Your answer will be equals to x I. Since this I will still be there. So this I itself is equal to, where I is equal to root minus 1 is equal to root. And normally if I have root minus d, I can say is equal to root d minus 1. And so the splitting it, I'm having root d times root minus 1. And since root minus 1 is equal to I, I'm having root d I. That's why I got that. So your final answer will be xi. So and your calculator does not know how to tell you that your answer is equal to, if you press root minus 4, it doesn't know how to type it that, okay, it's equal to what? 2i. So rather tell you it's a mass error because it is a complex number. So that's why you don't imaginary. So that's why the graph will always give you this. It's not cutting x at anywhere. It's not cutting, sorry, this is a wrong description. It's not cutting x at anywhere. So that's not about imaginary, and so it can come this way, provided it's not cutting the x at anywhere. So that's about the theory. So thank you very much. Don't forget to subscribe, like, and share. So meet you on our next class, hopefully. Thank you very much.